Question 15. The complex numbers z and w are such that z is equal to 1 plus ip and w is equal to 1 plus iq, where p and q are real and p is positive. Given that zw is 3 minus 4i, find the exact values of p and q. So one good way of starting this question would be to work out what is zw in terms of p and q. So zw is equal to 1 plus ip, 1 plus iq. And what is that? That's going to be 1 plus iq plus ip plus I squared pq. And so what is that going to give me? It'll give me 1 minus pq plus ip plus q. Right? So, what can I do? Well, I know that this is also equal to 3 minus 4i. So what does that mean? Comparing real and imaginary parts, real and imaginary, I can say that 1 minus pq should equal to 3. This will be my first equation. And that p plus q should equal to minus 4. This is my second equation. So what am I going to do? Well, I am going to say that if we look at this, that means that q is equal to minus 4 minus p. So we'll call that equation 3. And I'm going to sub equation 3 into equation 1. And so what does that give me? That gives me 1 minus p minus 4 minus p is equal to 3. So that gives me minus 2 plus 4p plus p squared equals to 0. Right? And so now I can use the quadratic formula on this. P is equal to minus 4 plus or minus the square root of 16, take 4 by minus 2, all over 2. It's just the quadratic formula. And then working this out, you get P is equal to minus 2 plus or minus square root 6. And so we reject negative because we're told that P is a positive number. So the answer is actually minus 2 plus square root 6. So that tells us P, but we still don't know anything about Q yet, but that's not too hard because we've got a very, very nice relationship where Q, sorry, let me just do this properly, sub P is equal to minus 2 plus root 6 into equation 3, and I get Q is equal to minus 4 minus 2 plus root 6. And so this is equal to minus 2 minus root 6. And so that's my answer of P and Q. Yeah, so I can say therefore P is equal to minus 2 plus root 6 and Q equals to minus 2 minus root 6. So what about the last part, part B? A complex number A is given by A equals to 1 plus I root 3. By using de Moivre's theorem, express 1 plus A squared plus A cubed plus plus A to the 9 in the form x plus I y, where x and y are exact values to be determined. So again, obviously I don't want to have to do this by expanding out every term. So I should try and find out what is the exponential form of A. So A equals to, and again, we can just draw out a quick Argand diagram actually. So we know it's in the first quadrant because both real part and imaginary part are positive, and it's 1 and then root 3. So again, this triangle I hope by now is starting to look familiar, even if it's terribly drawn like it is in this case. This should be a 1, 2, root 3 triangle, where this is the big angle because this is the big edge. So A is actually equal to 2e to the I pi upon 3. And I think we've actually worked this out previously in the same tutorial. So now I've actually got 1 plus a squared plus a cubed plus all the way up to a to the 9. And you may be wondering, well, where have I seen this before? This is actually the sum. This is actually the sum of the first 10 terms of a geometric series, right? Because a here is sort of like our common ratio. But if you're a little bit hesitant, I don't blame you, because you don't know, does this actually work where a is a complex number? We've only ever done it where we've given r a real number. So we should think about how we derive this. Well, recall, like, let s equal to 1 plus a squared plus a cubed plus da 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 plus a to the 9. And then let a times s equal to a. Actually, I'm not going to write it there. I'm going to write it 1 over. So I'd get a from 1, and then a times a gives me a squared, and then a squared times a will give me a cubed, plus da 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 da, plus a to the 9, and then a to the 9 will give me a to the 10, right? So I'd end up with this, and what am I going to do? I'm going to subtract one from the other. So what is s minus as? And that would give me, you see, these terms in here would all cancel, right? So I'm left with just 1 minus a to the power of 10. And actually I can factorize out my s. This is a 1 minus a is equal to 1 minus a to the power of 10. So the sum of my first 10 terms is going to be 1 minus a to the power of 10 over 1 minus a. And remember, s is equal to 1 plus a squared plus da 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 plus a to the 9. So actually this is, oh, where did that all go? Anyway, this is perfectly legitimate, right? I can use my finite sum for my GP. So what is this actually equal to? Enough proving things, let's get it actually done. This would be 1 minus 2e to the I pi upon 3 to the power of 10 over 1 minus 2e to the I pi upon 3. Right? And actually on the bottom line it doesn't make a lot of sense to write it like that, because I'm not going to be using it in, I'm not raising it to any powers, right? But I actually do have a minus 1. So, oh gosh, a lot of things happened there. I do have a minus 1. So what I want to do, sorry, let me just put this back up here, right? I might just leave this in its original form. So 1 minus 1 plus I root 3. Right? Okay, so now we're cooking with gas. What can we do? So this is actually equal to, the bottom line is just going to be equal to I root 3 minus I root 3, right? Minus I root 3. What about the top line? This will be 1 minus 2 to the power of 10 e to the I 10 pi upon 3. So what do I want to do here now? Well, this is, now I want to transfer, oh gosh, what happened there? 10 pi, right. So now I want to convert this back into Cartesian so I can take care of this minus 1. So what do I do? This becomes 1 minus 2 to the 10, and then I can do cosine of 10 pi upon 3, and that turns out to be minus a half, plus I, and then sine of 10 pi upon 3 gives me minus root 3 upon 2. And this whole thing is over minus I root 3. Right? And you can see there's a divided by 2 top and bottom, so I can make this 2 to the 9. So this is equal to 1 minus 512 minus 1 minus I root 3 over minus I root 3. And actually, if you do this, what do you get? This turns out to be, so you can see the imaginary part is going to cancel here and here, so I get this and this rather will cancel off, so I just get 512 for the real part. Minus 512 actually. Oh gosh. And then minus 171 root 3 times I. So that's what that simplifies to. And I'm sorry, I don't quite know. Sorry, that's not very clear. Let me just rewrite this again. No, that didn't work. Sorry, it gets a little unhappy if I have too much written on one page. Let's try it one more time. This equals to minus 512 plus 171 root 3 times I. And that is my final answer.